So let's put this idea into action. See what this does. Let's put these formulas into play and see what's happening. So here we go. So we have our first problem here where we've got um, an opinion poll that asks 1,785 adults whether they attended a church or a synagogue during the past week. And so it claimed that the opinion poll claimed that 60% of adult populations do not attend a church or synagogue during any randomly selected week. So that is the claimed amount. What's the probability that the sample proportion of those who did not attend is at most 58%? So what happens if we had come across, so we took our own sample and we just got 58%. Is that far enough away from this 60% to call into question this attendance rate, this 60% attendance rate? So the first thing that we want to do is state, what our mean of all our samples should be, because this is a sample of 1,785 adults. So here's what's happening. We're going to be collecting this type of data over here on the side. Okay, so here we have this information. We've got here that the claimed population proportion is 60% do not attend a church or synagogue. Then the sample size is 1785. So if you can imagine taking a whole bunch of 1785 people, a whole bunch of 1785 people, and seeing what those proportions are. See, we have a normal model filled with a whole bunch of p hats, a whole bunch of p hats of dots that are happening. Okay, so if we took a whole bunch of samples, our samples, if 60% is true, then our samples should center at 60%. And if 60% is true, then our standard deviation, the variability is not very big because that n is so huge. Anyway, so here's the math to that. We get that zero point 0.6 times 0.4 over n. So there is our standard deviation, 0.012. That's how varied our p hats are. Okay, so let's see. Is our 0.58 unusual? Well, let's get a z-score. So we're going to do our x minus the mean over the standard deviation, x minus the mean over the standard deviation. So when we do that, we've got our negative 1.67. So that in itself, what do you have to say about that? Is that an unusual sample? Okay, so hopefully you can say to yourself, no, it's not, because it's not even not more than two standard deviations away from what the claimed amount was. So that could be happening just because of sampling variability and the sample that I happened to get. Now, to answer the question, what's the probability that we get this particular sample and at most that amount? So then that's why we then are having this situation. This is our attendance rates centered at 60%. That 0.58 is 1.67 standard deviations below the mean. And so then that area that is at most 58%, so 4.75. So it's not, way easy to have that amount, okay? But there's about a 4.75% chance of getting that p hat if the claim of 60% is true. So that wouldn't necessarily make me freak out a little bit, okay? That wouldn't be, so I don't think it's particularly unusual because it's not more than two standard deviations. All right, so that's how you do that. So let's let you do this next one here. Here we go. A quality engineer is going to select a simple random sample of 300 items off of a large shipment. So I can envision this happening. You are the quality control person. You are deciding whether you're going to accept this shipment or reject the shipment and send it back. So you take a random sample of 300, and then you're going to see what proportion of them are defective. So this is interesting. Unknown to the person who is the quality control engineer, the shipment actually contains 9 defective switches. That means that's telling you the facts. That's telling you what the true population defective rate is. So that's the population defective rate, 9 out of 300. So that means the population, the whole shipment is the population, and it has 3% defective. Okay. And so then see, look, our sample size, 300. All right. The quality engineer will reject the shipment if he gets a sample of 300 and, actually the population, I guess, is a lot more than 300, but the sample he takes is just 300. So our sample size is 300. Our population is much bigger than that. Anyway, so if that 300 shows that more than 5% of the switches are defective, then he's going to say, hold your horses. I'm going to reject this shipment and send it back. So what's the probability that this quality control engineer will find more than 5% defective switches? What happens if he gets one of those samples that's more than 5% defective and reject that shipment, even though we know for a fact it only has 3% defective rate? Okay, so let's see here. So I'm kind of calling into question my wording on this. It only has 9 defective switches. I probably should say, per every 300. So I probably need to fix that. The intent is that it was not a population of 300 and that there is 9 out of every 300. Okay. Anyway, we're going to go with that. Okay. So we know that because the population has 3% defective, all the samples that the engineer will take, all the p-hats that he takes, should be centered around 3%. Well, but then let's find the variability, the standard deviation, 0.0098. So it's pretty small. Okay, so let's see what that looks like here. So here is our normal model, because our sampling distribution will be shaped like the normal model. And we know that this defective, all the p-hats are centered at 0.03. And we will reject it if we get one of these up here that is at 0.05 or higher. So let's get a z-score and then compute. So our z-score is that p-hat minus the p over the standard deviation of p-hats. And that's more than 2 standard deviations away. So it's actually, he would be getting an outlier result if he got 0.05. So that's good, because if it's really 3%, we don't want to reject it. So anyway, when we norm CDF, so that means there's only 2.07%, so just a little over 2% of all the samples that he could collect, random samples, that would make him reject that shipment. So that's good. So 98% of the time, he's going to get a sample and he'll say, all right, you're good to go. We accept your shipment. And they should, because it has only 3% defective. All right, so let's answer the questions here. There's only a 2.07% chance of finding a sample with more than 5% defective if the shipment really has just 3% defective parts on that. Okay, so I'm sorry about the clarification on that. Again, I need to reword this problem that the shipment actually contains, I should say, just 3% defective switches, 9 per every 300 or something like that. 9 per every 300. Okay. But anyway, there you go. So that's what you're going to be doing then on your assignment, is you're going to be working through these problems where you're given a scenario. You want to identify the population number, The sample size, use this as your guideline. You want to identify those things that I identified here. The true P, the sample size, the P hat that they get, and then what the mean and standard deviation are. And then do your math to answer the question they are asking. Okay? And so that's what you're going to do. There's just 5 of those for you to practice on. So let's see if you can understand your sampling distributions for your sample proportions. All right, good luck to you.